As an introduction, over the years, industry have experienced several major changes known as industrial revolution, each driven by new technologies that improve the way products are manufactured. These changes range from mechanized production using steam power to automated systems controlled by computers. Today, we are in the era Industry 4.0, where digital technologies connect machines, systems, and people in real time. Industry 4.0 help industry become more efficient, flexible, and competitive in global markets. In this presentation, we will briefly introduce the background of Industry 4.0 and then focus on system integration, which is one of the key pillars that enable smart manufacturing and intelligent industrial operation. History of Industrial Evolution. Industrial Revolution 1.0 began in the late 18th century and marked the shift from manual labor to mechanized production. During this period, water and steam power were used to operate machines, especially in the textile industry. This allowed goods to be produced faster and in large quantity compared to traditional handcraft methods. The introduction of factories replaced small home-based workshops, leading to the growth of industrial cities and new job opportunities. Overall, Industry 1.0 laid the foundation for modern manufacturing by introducing machines into production process. For Industrial Revolution 2.0, the revolution took place in the late 19th and early 20th century and focused on mass production. The main driving force of this revolution was the use of electricity, which made factories more efficient and flexible. One of the key developments during this period was the introduction of assembly lines, which allowed products to be manufactured in large quantity at lower costs. Standardized parts improved product quality and consistency. Industry 2.0 significantly increased industrial productivity and made products more affordable to customers.
Now, let us proceed to the history of Industrial Revolution 3.0, that known as the Digital Revolution that began in 1970s. This IR generation focused on the automation of manufacturing processes through electronics, computers, and information technology. This era introduced digital control systems that enable more precise and reliable production operations, which introduced robots in mostly in heavy industries. Technologies such as programmable logic controllers (PLC) and computer numerical control (CNC) machines were widely adopted to automate repetitive and complex tasks. These systems reduce human error, improve production accuracy, and enhance workplace safety. Proceeding to the IR 4.0, the Industry 4.0 refers to the fourth industrial revolution, which is characterized by the seamless integration of digital technologies. Unlike previous industrial revolutions that focus on primarily on mechanization and automation, Industry 4.0 emphasized connectivity, intelligence, and real-time data exchange across the entire production environment. Now, what are the importance of Industry 4.0 in modern industry? So, the important role in transforming traditional manufacturing into intelligent and data-driven operations. The main advantage of Industry 4.0 is increasing productivity through automation and real-time monitoring. By using real-time data, manufacturers can monitor the processes more accurately and improve production efficiency. This also improves decision making across the production lifecycle by enabling seamless data exchange between machines and management systems, and allows faster responses to operational issues and better coordination of manufacturing activities. Okay. Now, what is system integration? The system integration combines different hardware and software subsystems into a unified environment. This enables communication, data sharing, and coordinated operation across systems. The quality impact of this integration are fewer manual transfers, more consistent data records, and better traceability. In quality management, this matters because quality decisions require reliable records that are updated consistently. Now, there are five fundamentals method of system integration. The key is to choose the right approach to affect scalability and maintenance. The first one is point-to-point integration. This method directly connects between two systems, but it is hard to manage when it's applied in a bigger scale. Next, vertical integration. This method links operational layers upward. This method can be seen when the shop floor and the enterprise planning is conducted. Next, horizontal integration. This method uses multiple point-to-point links forming a hub-like structure which can increase complexity as the system grows. This method can be seen in cross-department and value chain visibility. Next, star and common data format. This connects departments and partners across the value chain for end-to-end visibility. Lastly, common data format integration. This standardizes the data format exchange across systems to reduce repeated transformations.
Okay, my name is Muhammad Hasif Osman and I will be continuing the presentation of this Industry Revolution 4.0. So next is the important factor in integration system. So there are several factors that is important in system integration. First is data flow, second is integration need, urgency, master data and source of truth. So first let's see the data flow. Data flow is how the data move between the system. So why this is important? Because if the data is slow or incorrect, data will tend to make the system tend to make a wrong decision and or have a high latency, making our system unquality, less the quality of our system. Next is integration needs. So we need to make sure what's the purpose integrating the system. We need to have the real purpose in integrating our system. So it is matter to keep our project optimized and low cost as possible. Okay, moving on. Another factor of system integration is source of truth. So it is important to avoid conflict records. So we need to make sure that our data is valid. Next another factor is urgency. So urgency is it's about time. So it is matter because if the urgency, if the integration system have high urgency, it can cause an error. So it require a good amount of testing and validation to avoid from causing error to the system. Okay, finally the last factor in system integration is the master data. So master data is for the standard reference data shared across the system, like code, bills of material, supplies ID, batch, and a lot of data, a lot of numbers. So this is matter because if the data is inconsistent, integration might work, but it will produce the wrong output since the data provided will be wrong. So this is like the database that we need to keep them preserved. Okay, now we will be moving on about the overview ecosystem of the integration system. So this you can see that we have a lot of system that can be integrated with each other, interconnect and communicate with each other. So a lot of combination for the system to be integrated with each other. So the system integration can be understood through an ecosystem view, where multiple system exchange data through unified integration layers, as illustrated in the figure. Integration commonly link enterprise operational systems such as CRM, accounting, user payment, retail, office system, post kiosk, and phone tablet. So this is just for the get the overview of how much possibility that this integration can be from our phone, from our tablet, to from everyday use to much more industry use such as the CRM, accounting, and retails. Okay, next we'll be moving on to the life cycle overview of implementation of integration system. So this, you can see the diagram is the simple life cycle consists of design and planning, implementation and integration, and management service. So first we see first step is the during the design and planning is the first step. The organization will define the scope, integration requirement, and the quality critical data that must be remain accurate. After that, is the implementation integration. The system we are connected. So this is the part that we connect the system to integrate data mapping and configure the system and verifies that it's working properly. And then finally we have the managed service. So managed service provide continuous monitoring, configuration control, fault handling to keep integration stable for a long period of operation. This like the same as before. As before, we already make the system integrated and implement them. This time we just we want to keep maintaining and make the system running and operate as it should be.
System integration plays an important role in improving quality management in Industry 4.0. By integrating different systems, duplicate records and manual data entry can be reduced, which improves data consistency across departments. Integration also strengthens traceability because production batches, inspection results, and inventory data are connected within a single workflow. This makes it easier to track quality issues and identify their sources. In addition, faster decision making is possible when information is updated and shared in near real time, allowing organizations to respond more quickly to process variation and quality problems. Despite its benefits, system integration also presents several challenges. Complex integration networks, especially those using many point-to-point connections, can become difficult to maintain and troubleshoot as systems grow. Another challenge is poor master data management. When there is no clear source of truth, conflicting records may occur, reducing reliability of quality reporting. Furthermore, integration increases dependence on system availability and security. Without proper controls, system failures or security issues can cause operational disruptions and negatively affect quality performance. In conclusion, system integration is essential in Industry 4.0 because it connects different systems and allows data to flow smoothly across the organization. It supports quality management by reducing manual errors, improving traceability, and enabling faster corrective actions. Overall, effective system integration helps organizations operate more efficiently while maintaining consistent and reliable performance in a highly digital and interconnected environment.